Since we're talking about slope, we might as well include slope-intercept form for the equation of a line. That way we can graph and recognize equations. Y equals mx plus b. Remember that? What are the parts of this equation? Well, we just finished talking about how slope is that lowercase m, so the m represents the slope. The b, we're not going to need to deal with too much today, but the b is the y-intercept. We'll get into that more another time when we're graphing more. Let's right now use slope-intercept form for these examples. For numbers 8 through 11, find the slope of each line. So that's first. Then tell if the lines are parallel, perpendicular, or neither. So remember, when it's in slope-intercept form, the coefficient of the x, the number in front or multiplied to the x, is the slope. So in the first one, y equals something x plus something. Remember, the coefficient to the x is the slope. So the first slope is 4. I'm going to call that slope of line 1 since it came first. The next one, here's the slope in front of the x, just like this one, just in front of the x. That's all I'm looking at. This one, the second slope, is negative 1 over 4. So I found the slope. What do these slopes tell me? Well, remember, if I multiply them, well, first of all, they're not the same, so the lines can't be parallel. They're different, so let's try to multiply them. If I do, I get negative 1. The product being negative 1 means these lines are perpendicular. So that's my final answer. These lines are perpendicular. Now look at the next one. Notice the y is not by itself. It doesn't say y equals mx plus b style. So we have to make it say that. Let's solve for y in this first equation. I need to move the x's over, so I say minus 3x on both sides. Negative 2y is left over, equals negative 3x. I'm going to put the x first because mx plus b is what I want it to look like. Then 3 plus 3. Now I'm going to divide by this coefficient, negative 2, and I do it to every term. When I divide by negative 2, now the y will be by itself, and this says 3/2 x minus 3 over 2. Let's look at this one. First, subtract 3x. Now I have negative 2y equals negative 3x minus 8. I can divide by negative 2, and that gives me y equals 3/2 x plus 4. Once I have it in y equals mx plus b, I'm looking at the coefficient to the x. This one is 3/2. This one is 3/2. The slope of line 1 is 3/2. The slope of line 2 is 3/2. They're the same slope. So what does that mean about these lines? That's right. They are parallel. That's my answer, parallel lines. Let's look at another one. This doesn't say y equals mx plus b style, and it doesn't even have a y in it. It's x equals a number, and x equals a number. Remember earlier we talked about when it's x equals, that's our Vux situation, when it's x equals. And what does the v in the Vux mean? The v means vertical. So these are two lines that are vertical, both straight up and down. I don't have to do any work for these. I know that they are undefined slopes, and therefore the lines must be parallel because they're going in the same direction, up and down, parallel lines. Do you want to take a look at the next one on your own and come back and check your work? So here we have a y equals. This would be our hoi. Here we have an x equals. This would be our Vux. So what does that mean about these two lines? Horizontal, and vertical. Doesn't really matter what the numbers are. When I have a horizontal and a vertical, they're going to cross each other at a right angle. They are going to be perpendicular. Let's write down the slopes though, since that was part of our assignment in directions. So y equals, slope is 0. Slope of line 1 is 0. Vux, x equals, slope is undefined. So the slope of line 2 is undefined. Either way, they are going to cross at a right angle, so my answer is perpendicular. Now, the talk of parallel lines wouldn't be complete without being able to construct a line parallel to a given line through a point that's not on the line. So we're going to, very similarly to how we did for perpendiculars, construct parallels. So first of all, notice what you're given. You're beginning with a point P and a line K. Point P, line K. That's what you start with. Now, remember when it says go through a point, that is where we need to start. So our second step in this is drawing an arbitrary line. Arbitrary means it doesn't matter where it goes through this other line. I could have drawn it like this, I could have drawn it like this, it really doesn't matter. But I picked one place and I drew that line. Make sure it goes through point P and intersects the line that's given. So draw that line. So we're given a point, we draw that line. From there, notice that we've created an angle. Do you see this angle that's right here? Right here, this angle, we've created this angle. Well, we are going to copy that angle. Remember how we copy an angle. I'm going to take my compass, put it on that vertex, and I'm going to draw an arc that goes through both sides of my angle. So after this point, after I have an angle, I'm copying an angle. I draw this arc, I move up to the other point, and I draw an arc that is approximately the same size, if not identical. So the point here is we have an angle, we've created an angle, now copy the angle. Now copy this angle at point P. So we're copying this angle. So remember what we do after we draw these two arcs, we have to measure the distance between those two sides of the angle. So at these 2 points where the arc crossed, now we take our compass, we might need to rotate it a little bit, and I need to shorten it to measure the distance between those 2 points that the first arc made. Then I can go over here and I need to draw myself a little arc. But notice I don't need to draw it here because they already intersect, so I'm going to need to flip around my compass and draw it down here. So maybe we measure it like this to begin with because we know we can just move it like this. So I'm going to put the center of my compass here to draw that arc. So perhaps you make yourself that note where they're showing the little arcs. So the center of the compass goes here, center of compass first goes here, then we can move it over here and draw that little arc. Okay? Draw that little arc, and then we can see where it crosses. Finally, it's just a matter of drawing that line that will be parallel. So now we get our straight edge and pull it over and connect where we have our little intersection from that point. And notice you have 2 congruent angles, but the real goal here, we have 2 parallel lines. Let's summarize. Explain the difference between the slopes for lines that are parallel and lines that are perpendicular and lines that are neither of these. Thanks for playing. See you in class.